Welcome to the lesson of control valve spare management. In this particular lesson, we will learn about how to manage the control valve spare and what spare should be procured and how should be procured, and what are the best practices that needs to be followed. So in a big refinery or petrochemical complex, the control valve spare constitute a major portion of the overall instrumentation spare, cost wise and also the number of item wise. So it requires a special attention, and if you carry out the spare management thoroughly and accurately, you will be very good position to manage the overall instrumentation maintenance, and also cost wise you can reduce some money for the company. So first you should what if you are just starting the plant, and it is or you want to start doing the spare management from the scratch. You should do a plant walkthrough and gather all the data related to the valve. You should make a register. Either you can do it manually, or you can maintain one Excel sheet, or you can tabulate the data and feed it into your SAP system or CMMS system, where by just entering the equipment tag or the valve tag, you can access all the data about the valve. By data means you should have the make, model number of the valve and the actuator. Also, the serial number of the valves are often required by the OEM at the time of the spare procurement. Unfortunately, there are only few major valve vendor who had the specific part number for all the spares. Otherwise, all other vendors, what they do, they supply the spare by the name of the valve. So they made the spares almost unique. So for each valve there are unique spares are there. But if you carefully study these things, this is not like that, and there are certain models or certain specifications that can be followed by a group of valves. So after you have all the data, you should plan for the which part is to be replaced, like whether the soft parts needs to be replaced or the hard part need to be replaced. Frankly speaking, about 90% or 80% of the valves, control valves, hard part replacement will not be required in its lifetime, which means like around 15 years of lifetime. Hard part required replacement is required for maybe only around 80% of the valve, only around 20% of the valve. Remaining 80% of the valve you need to replace the soft parts. That means the gasket, the seat, the o-ring, these parts of packing, these parts needs replacement. So what spare philosophy you should follow? The best practice is to you codify or you make a list of all the spares that is required, and make it available in the SAP system or CMMS system, or maintain one Excel, and buy the soft parts of all common valves. So if you have a 10 valve of same times, you buy around 30% of the 40% spare. And for the case of the hard part, you define criticality of the valve. If the valve is very critical, or if the valve is in severe service, or if there is a history of damage of hard parts, then you buy the hard parts of only that type of valves. For all other valves you buy the soft parts, and also in that case, buying of the soft parts, you group them into categories. Like you have one kind of valve, suppose 100 numbers of X kind of valve, then you have 100 numbers of Y kind of valve. So accordingly, this grouping you buy the spares. Another thing is turnaround planning, which is very important, and you need to define that what should be the overhauling frequency of the valve. I- what overhauling frequency should you uh, follow. So for the critical valves, you can, like overhauling, you can plan in every 4 years or every 8 years, and for non-critical valves you can plan the overhauling in every 12 years. Now the problem with overhauling all the valves in the turnaround or all the valves in the shutdown is the shutdown window is very small, and within that window you have to complete, if you try to complete the uh, overhauling of all the valves in the complex, it will be huge tasks, because the capacity of the workshop is limited, also the mechanical team is also limited. So after you decide the overhauling frequency of the valve, you need to normalize the quantity of the valve that needs to be overhauled in the turnaround or shutdown according to the criticality of the valve. If the valve is such that the failure of the valve may reduce to production loss or environmental issues or safety issues, you take that valve for overhauling in every shutdown. Or another criteria may be that if the valve does not have any bypass. So if that kind of valve needs to be overhauled in every turnaround. Also, you use the help, take the help of the diagnostic software and check the which valves having problem, and the identified valves should be also overhauled in the turnaround or shutdown. The spare details you should take, like I have given one example, this is for the ball valve only. So for the case of the ball valve, you should take the spares of the ball, you should take the spare of the seat, and you should take the repair kit. Repair kits means all the gaskets or in that's are required for overhauling. So this is a typical ball valve, floating ball valve. As you can see, this is an exploded view of the ball valve, and it contains lots of materials. So you should make this exploded view of different type of the valves and identify the spare parts, and then discuss with OEM and freeze the number of items that are required and at to which quantity, and map all these things in the equipment and update the bill of material of that item in the CMMS. This is again a trinion mounted ball valve, exploded view, and with the list of items that are required. So this is just an example. In a similar way, you can make the bill of material in the SAP system. So this is just a brief idea about the spare management of the control valve and on-off valves. If you when we have doubt, you please write in the question answer section, and if you have any special requirement, I will make more videos on this topic. Thank you.